We have two presentations more. Professor Ivan Kurdish from the Institute of Microbiology and Virusology, Zabulotny. Thank you, dear organizers and participants of this event. Each of us is aware that in using the chemical fertilizers and pesticides helps us to have good crops and yields, but at the same time it pollutes the environment and negatively impacts the health of people. Therefore, in the recent decade, in most countries, the proper trend is to cut down using these particular fertilizers in the agriculture. The fertility of the soil and development of plants depends on microbiotics. In every gram of soil, there are about 10 powers of 9 cells and microorganisms, of which there are 4,500 types. So this microbiota, of course, impacts the fertility of the soil and growth of the plants. Among these microorganisms, a huge part is represented by phytopathogens. Therefore, a very pertinent problem in horticulture is to correct by bacterial methods and the microbial substances are produced as form of suspension, each one containing one strain of microorganisms. But the most promising, we think, are the preparations that contain 2 or more strains, which facilitate the synergy in the development of the plants. So the highly effective strains of nitrogen-building bacteria, Azotobacter williandi and Bacillus subtilis, IMVB 7023, and using of these 2 strains allows to considerably improve nitrogen and phosphorus nutrition of plants, to synthesize a number of phytohormones, and they are antagonistic to a wide range of phytopathogenic bacteria and fungi. We have conducted a wide scope of research of the strains that we selected, of different nature, and we have seen that introducing nanomaterials of different nature, dioxide, silicium, natural minerals of palygorskite, and others, come into contact, into interaction with these particles, which results in increased bacteria growth rate and their biochemical activity, including phytohormone synthesis. In this case, we see the increased growth rates of bacteria, the movement activity, and, as we said, phytohormone synthesis, plus cooperation of nanoparticles with montmorillonite, palygorskite, bentonite, and other nanomaterials. The virility of bacteria significantly increases under the influence of heightened temperatures and during the prolonged storage. Considering this and other properties of clay minerals, as well as the interaction of bacteria with bentonite nanoparticles, we created a new granular complex bacterial preparation. Our preparation have grains of 0.25 gram. In each of this grain, 10 powers of 8 cells is contained, it is very well stored, whereas in liquid form or form of suspension, it quickly loses its properties after a month of storage. And this preparation, of course, effectively impacts the growth and development of plants, which you will see later. We took, for comparison, the strain of Azotobacter vinylandi, a Ukrainian collection of microorganism, and we have identified that introducing 2 grains of preparation into the root zone of tomatoes allows to improve the yield by 19%. The granulated preparation based on selected strains increased the yield of these crops by 28%. The complex bacterial preparation with selected microorganisms increased the yield by 37%, and even based on the collected strain by 31%. Granulated bacterial preparation increased the yield of potatoes, vegetables, um, and other crops. Introduction of 1 grain into the roots of roses increased the number of buds by 45%. The 2 grains produced a lower effect, maybe due to increased growth stimulants content, just as medicines for humans should be dosed properly. The granulated preparation caused observable stimulation for other flowers and the lawn grasses. This table shows the impact of granulated preparation on decorative plants. 1 grain of the preparation into the white cedar sprouts increased by 70%, fir cone 15, boxwood 10. So therefore, granulated complex preparation allows to improve the growth and development of flower, decorative and other plants, and obtain environmentally clean yield of various crops, potatoes, the sugar beet, and other. But in order to use this preparation for grains and for cereals, you have to prepare the suspension before the harvest in order to conduct effective bacterization. Therefore, but it's not convenient. Therefore, we decided to create our own version of suspension for cereals, and we found that the best basis or the primer is the vermiculite. Vermiculite nanoparticles is the result of this effort. The vermiculite plates are 10 nanometers in size, but if it's granular structure, it provides a heightened growth rate, different growth rates. But in order to solve this issue, we developed a technology that allows to have in a gram of granulite to 10 in powers of 9 cells, and this preparation is also very stable in the storage. And I think the both granulated and fine granulated are going to be very well marketed in Ukraine. To improve the adhesion of bacteria of the fine granulated preparation, we prepared the base of natural nanomaterial, which improves these qualities. These developments are patented in Ukraine. The strain of Azotobacter vinolandi, the strain of Bacillus subtilis, the technology of bacterial preparation in granule form, and the surfactant form, also patented, the medium for cultivation of Azotobacter vinolandi, and the medium for cultivation of Bacillus subtilis. We also filed an application for patent for the complex Vermiculite preparation. This is some of my contacts, and thank you. Okay, thank you. I have some question. You started to answer it in your presentation, but of course the bacteria are growing with different rates. But those bacteria that grows faster are not always more resistant than other bacteria. Is there a competition between your bacteria for survival? That's the first question. And secondly, have you looked into the impact of your preparation to resistance of plants to other Fictobacteria? For instance, you mentioned tomatoes. Maybe the viruses that tomatoes are susceptible to, so resistance is different. Yeah, it's a good question, and I had no time to tell about it. But let me tell you that our preparation protects the plants against phytopathogens. Dephitopter, which is rarely met in agro system of tomatoes when used granulated preparation that we created. And moreover, we know today that our preparation, to a certain extent, protects the potatoes against the bug, because the bacteria synthesizes proteins that inhibit development of Colorado beetle. More questions. When the yield is increased, doesn't it lose its qualities? Because you can buy very large tomatoes in the shop, but they taste bad. No, we haven't looked into it, but I dare to say that our registered granulated preparation is registered as Azogran, and we sold this license to Enzym Ladizhinsky Zavod. In the Soviet time, it was the most powerful plant in Europe in this field. No more questions? Thank you. The last question. Are there any foreign analogies, and what is the price? We have developed the first complex preparation in Ukraine, although the foreign analogies are there, of course. I have never seen in the literature any data that the yield of tomatoes is increased by 37%. And the tests were done on a lot of companies. And the Kiev, the director of the Kiev horticulture factory, she was saying, "How do you do that? Because I'm giving them everything." I say, the bacteria are better. Okay, the